Imagine a lone satellite orbiting silently in the vast expanse of space. It has been a steadfast companion, tirelessly circling our planet, a silent sentinel in the night sky. This satellite has witnessed countless sunrises and sunsets from its lofty perch, a marvel of human ingenuity and perseverance. For years, it diligently relayed communications, gathered data, or observed distant stars. It played a crucial role in connecting people across continents, advancing scientific knowledge, and expanding our understanding of the universe. Each signal it sent and received was a testament to its vital role in our technological ecosystem. But its mission is over. Its power dwindles, its instruments fall silent. The once vibrant and active satellite now drifts aimlessly, a relic of its former self. It has served its purpose, and now it faces the inevitable end of its operational life. What becomes of this celestial retiree? Unlike old cars or appliances, we can't just tow satellites to a scrapyard. They remain in orbit, becoming part of the growing collection of space debris. This debris poses a significant challenge for future space missions and the safety of operational satellites. Space is different. It's a delicate ecosystem where every action has lasting consequences. The accumulation of space debris can lead to catastrophic collisions, creating even more debris in a dangerous chain reaction known as the Kessler syndrome. This makes managing and mitigating space debris a critical task for scientists and engineers. So, how do we say goodbye to these technological pioneers without jeopardizing future space exploration? The process of decommissioning satellites involves careful planning and execution. Engineers and scientists work together to ensure that these satellites are safely removed from orbit or placed in a designated graveyard orbit. The answer lies in understanding the final resting places for these celestial workhorses. Graveyard orbits are designated areas where decommissioned satellites are moved to reduce the risk of collision with operational satellites. This helps to keep our orbital environment safe and sustainable. As we venture further into the cosmos, it becomes increasingly important to address the fate of our spacefaring creations. The lessons we learn from managing space debris today will shape the future of space exploration and ensure that we can continue to explore the universe safely and responsibly. Join me as we explore the fascinating and sometimes unsettling world of space graveyards and the quest to keep our celestial neighborhood clean. Together we will uncover the challenges and solutions in managing the final frontier, ensuring that space remains a place of wonder and discovery for generations to come. And when a satellite reaches the end of its operational life, it doesn't just stay put. These technological marvels, after years of service, face a new challenge. Leaving it in its operational orbit would create a hazard for other spacecraft and satellites. The crowded orbits around Earth are already bustling with activity, and adding defunct satellites to the mix would only increase the risk of collisions. Instead, we send these space veterans to a special place, a space graveyard. This process involves carefully maneuvering the satellite to a designated orbit, far from the busy lanes of active satellites. Don't picture a cosmic cemetery with tombstones and epitaphs. These graveyards are invisible to the naked eye, vast expanses of space where these silent sentinels can rest. These graveyards are actually designated orbits, far removed from active satellites and space stations. They are chosen to minimize the risk of interfering with operational missions. They act as cosmic parking lots for defunct satellites, spent rocket stages, and other space debris. These orbits are carefully calculated to ensure that the debris remains out of harm's way. There are a couple of these orbital retirement homes. Each one serves a specific purpose, depending on the type of satellite and its original orbit. One popular choice is a high-altitude graveyard orbit, positioned thousands of kilometers above Earth. This orbit is far enough to avoid any interference with active satellites and space stations. Here, the risk of collisions is minimal, allowing these relics of the space age to drift peacefully for centuries, if not millennia. These silent guardians of our technological past continue their journey, far from the hustle and bustle of Earth's active orbits. For satellites residing in geostationary orbit, a sweet spot approximately 36,000 kilometers above Earth, the journey to the graveyard takes a specific route. Enter the Geostationary Transfer Orbit, or GTO. Imagine a satellite in geostationary orbit diligently beaming television signals to your home. As its operational life concludes, it performs a final maneuver. Using its remaining fuel, it boosts itself into a slightly higher elliptical orbit, the GTO. This maneuver serves a crucial purpose. It ensures that the defunct satellite doesn't interfere with the bustling traffic of operational satellites in geostationary orbit. Instead, it gracefully retires to a higher, less congested region. While some satellites find their final resting place in distant graveyard orbits, others meet a more dramatic end. For smaller satellites orbiting closer to Earth, our planet's atmosphere acts as a convenient disposal system. Earth's atmosphere, while essential for life, also creates friction. As a satellite descends from its orbit, it encounters increasingly dense layers of air. This atmospheric drag slows the satellite down, causing it to heat up dramatically. The intense heat generated during this fiery descent is usually enough to incinerate the satellite, breaking it down into smaller, harmless debris. It's a spectacular, albeit uncontrolled, way to dispose of space junk. Section 5. The looming threat: space junk and its dangers. The increasing number of defunct satellites and fragments of space debris pose a growing threat to our spacefaring future. These remnants of past missions, often left behind without a second thought, now clutter the orbits around our planet. This orbital debris, traveling at incredibly high speeds, can collide with operational satellites, spacecraft, and even the International Space Station. The sheer velocity at which these objects move makes even the smallest piece a potential hazard. Imagine a tiny fleck of paint traveling at thousands of kilometers per hour, smashing into a delicate solar panel. The impact can cause significant damage, rendering the equipment useless and creating even more debris. Or a derelict rocket stage colliding with a manned spacecraft. Such an event could endanger the lives of astronauts and jeopardize entire missions. The consequences of such collisions can be catastrophic. Not only do they pose immediate threats, but they also contribute to a cascading effect known as the Kessler syndrome, where each collision generates more debris, increasing the likelihood of further collisions. This space junk doesn't discriminate. It threatens everything we've sent into space, from communication satellites to scientific observatories. These vital instruments are essential for our daily lives, enabling everything from GPS navigation to weather forecasting and scientific research. Addressing this growing problem is crucial for the sustainability of space exploration and for protecting the valuable infrastructure we rely on here on Earth. Innovative solutions such as space cleanup technologies are being developed to tackle this issue head-on. The future of our ventures into space depends on our ability to manage and mitigate the dangers posed by space junk. Section 6. Cleaning up our act: deorbiting and controlled re-entry. To mitigate the risks posed by space junk, space agencies and companies are developing innovative strategies for managing and removing orbital debris. One approach is deorbiting, a controlled re-entry process. Satellites designed for deorbiting are equipped with propulsion systems that allow them to alter their orbits at the end of their operational lives. By firing their thrusters, these satellites can lower their altitude, guiding themselves towards a controlled re-entry over a designated area, typically a remote part of the ocean. This controlled descent ensures that any remaining debris from the satellite will fall harmlessly into the ocean, minimizing the risk of damage or injury on the ground. Section 7. A collaborative effort: international cooperation for space sustainability. Addressing the challenge of space debris requires a global effort. International cooperation is crucial for establishing responsible space traffic management practices and for developing technologies to remove existing debris. Space agencies worldwide are working together to share data on satellite orbits, assess collision risks, and develop guidelines for spacecraft design and disposal. International treaties and agreements provide a framework for responsible behavior in space, emphasizing the importance of long-term sustainability. By working together, we can ensure that space remains a valuable resource for future generations, free from the hazards of human-made debris. Section 8. Looking ahead: innovative technologies for space debris removal. While deorbiting is an effective strategy for managing future satellites, what about the existing debris already cluttering Earth's orbit? This is where innovative technologies come into play. Scientists and engineers are developing a range of concepts for capturing and removing space debris, from robotic arms and nets to laser systems that can nudge debris into different orbits. Some proposals even involve using large adhesive space flypapers to collect smaller debris particles. These technologies are still in their early stages of development, but they hold the promise of cleaning up our existing space junk and ensuring the long-term sustainability of space exploration. Section 9. Conclusion. Preserving the final frontier. As we continue to explore the cosmos and rely on space-based technologies, it is our responsibility to address the growing problem of space debris. By understanding the fate of our celestial creations, adopting responsible space traffic management practices, and developing innovative cleanup technologies, we can preserve the pristine beauty and scientific value of space for generations to come. Just as we strive to protect our oceans and forests here on Earth, we must extend that same sense of stewardship to the final frontier. The future of space exploration depends on it.